Alright, hello and welcome and a happy new year. In this video, I'm going over building a global stock screener with Python. What you see here is the final product, a dashboard where the user can pick a couple of things and can see some insights into the global stock markets. Now, first of all, let me guide you through how this dashboard is working. And let's actually take a look at some of the results. I think they are quite interesting. First of all, the user can pick the markets you want to include in the analysis, and then the results will update accordingly. So you see, I've picked the Nikkei, Japanese index, the Hang Seng, Hong Kong/China index, S&P 500 America, and the Indian index, NIFTY 50. Now, if you change that, the analysis will only go on the picked indices or index here. So you can extend that again, and then you see how the dashboard is updating accordingly. Now, what exactly does this show here now? So you see, I select a metric to rank. So in this case, out of a couple of metrics here, I picked the market cap in US dollar. Then you have a sorting order, descending or ascending, and a number of stocks to display. So in this case, I picked 10 stocks. So you will get the top 10 stocks, because I picked descending here, by market cap. And not very surprisingly, we have Apple very closely followed by Nvidia at the top. You know, Apple, the company which is worth the most on the exchange. Closely followed by Nvidia. Couple of weeks ago, Nvidia even took over the first place. But anyhow, you get the point of what this is showing here. So if you extend this by, let's say, the top 20, you will get the top 20 here. And you see this is America dominated. As you know, America is the biggest capital market in the world by a mile, literally. So you see, if you scroll a bit down, you will get a Chinese company, Tencent here, very popular tech/entertainment, or most probably rather a conglomerate. So they do a lot of things with a market cap in the top 15 at least. So you have a Chinese company here. But overall, even the top 20, if you compare those indices, are dominated by American companies here. All right, so let's actually extend that even more, 30 here. So we get another Chinese, this is also a very popular one, a bank, ICBC. And then we have a Japanese company here, which is Toyota. So also one of the probably most known companies worldwide. Now, this chart is also an interesting insight. This shows you the market distribution of top stocks here. So how do you read that? So out of the top 30, taking those indices into account, you have 27 stocks from the S&P 500. You have one stock, as we just saw, Toyota, from the Nikkei, and two stocks from the Hang Seng. So you directly see the distribution of the stocks here. So if you pick top 50 here, you will see that America 47 we have Hang Seng 6. Then we even have a NIFTY stock here. Which one is that actually? Quite interested in that. Reliance, also a popular petrol company here. So pretty cool, pretty interesting. So you saw I'm quite fascinated by this myself. I found this very interesting. You can extend that, of course. You can add more markets here. So you can compare the global stock markets. So actually do that. Add your domestic market here and see if it can compete with the other indices. But these are quite big indices. Now another one, let's just quickly go through it is the price earnings ratio. This one you would rather sort ascending because you want to buy those which have a low price earnings ratio. So that's at least what the fundamental people will tell you. And you see we have Oki Electric here as the lowest one, followed by a couple of Chinese companies here. We have a domination of Chinese. You see here 10. Then we have 1 NIFTY, 8 Nikkei, and only 1 S&P stock if you sort by the price earnings ratio ascending for the top 20s. Also quite an interesting insight, at least in my opinion. So I don't want to bore you, but last but not least, dividend yield, also an interesting one. So you would sort that descending rather. So you see you have, 12%. What even is that? I don't know. This one, Hang Lung. I have to look that up after this video. CCB. Then you have Walgreens Boot Alliance. 10% for an S&P 500 stock. Quite remarkable. Then Coal India also paying a lot. Have to compensate for the eco footprint. I'm just kidding. But yeah, I mean, you get the point, so you can check out for yourself. I found this super interesting, but let's move on to the coding part so you can build that yourself. Let us get started importing some necessary libraries. Pandas for data handling, YFinance to download all relevant stock information, and time to utilize the sleep function to avoid hitting API rate limits. Next, I'm going to read in a CSV file which I've created containing a bunch of ticker symbols for those indices. It was quite some work to put that together. I will upload that onto my members drive. So if you watch my videos, if you follow me on this channel, consider becoming a channel member. It appreciates my work and also makes future content possible. So if you watch my videos, become a channel member. You will get access to this list here, but obviously you can also just collect this data for yourself. So in a nutshell, you just browse through all those indices, Nikkei, NIFTY, S&P, and what was the other one? Hang Seng, and then you collect all ticker symbols. So you see I have them in here, and you already see I have only 415 rows, so I have not covered all S&P 500 stocks, just a share of them. So I have covered all Nikkei stocks, all NIFTY stocks, all Hang Seng stocks, and only a share of the S&P 500 stocks here. Now, next, you basically just want to pull the stock information for all those tickers here. And I'm going to show you, before doing the loop over all those tickers, I'm going to show you how this is working for a single one. So let's take an example here. Let's define stock and then use YF ticker, and then just pass this Nisui Corporation. So just this ticker here. And then you just pull stock info and call that, let's just call that info for now. And this will give you a bunch of information, a lot of useful information. You even see the management people here and just a ton of information. So go through it and check what you're interested in, because this is what you can cover then later on in your analysis. I just filter for just a couple of things. You already see here, right? You even get the beta, the trailing PE, the volume, bid ask, market cap, and so on. Just take a look at that for yourself. There are a lot of useful information here. An important one is, where do we have it? The currency. Because the information might be in a different currency than US dollar. Where do we have it here? Let's quickly, currency. You see this stock is in yen. So if you want to consider the market cap and want to compare it to an American stock, you have to convert this to US dollar. We will do that in some minutes, but just that you're aware, and this is a good time to go over that. So this market cap is in yen and not in US dollar. So you have all the info. Now you just filter. And how do you filter? Just as an example, you just use info get, and then let's take the market cap for instance, and then you get the market cap here as a number. Then you can, by the way, also use get and provide something if it's not available. So you can do it like this, and then you will get NA value if that value is not available. This is what I will do. So now you just get the information you're interested in. So also can take price earnings ratio here, and then you will get an NA value in this case, because this doesn't have any PE ratio. Good example here. This is how it's working. So let's cover all those stocks and pull all the relevant information. We are doing that in a loop. So for ticker in tickers DF ticker. So we just want to go over this list here containing all tickers, and then you do exactly what I just did. So you can print here fetching info 4, and then you provide the ticker here, just that you see where the loop is currently at. Just an optional step here. And then, as I just did, stock equals YF ticker, and then the ticker, then the info equals stock info. Then you have all the information, and now you just have to filter this information. And by the way, before you start the loop, you have to store the information somewhere. So I'm just calling that screener data and populate this empty list within this loop. So we are going to append, and now it's going to be some lines of code. So first of all, we want to have the ticker. This is going to be the ticker. Then we also want to have the company name, that we actually know what this company is, and that is simply info get long name. And then if that is not available, we want to have NA. And now let me just copy paste all the information we need over, because I don't want to waste your time. So market cap we need, price earnings ratio, dividend yield. Here we are. So market cap, price earnings ratio, dividend yield. Sector, I also found this very interesting. Then the industry and the currency, super important. So if you get a currency, it's just getting the currency. If not, it's going to default to US dollar. So with that, you just append to that screener data for the tickers, and you get the information you're interested in. Now, I would set a sleep timer after each iteration, otherwise you might hit the API rate limit here. So let's run this loop. And then you see fetching info, and so on. You can also print out info fetched here if you want. And this will take at least 400 seconds or 415 seconds, because we stopped the loop 1 second after each iteration. So let me just fast forward at this point. After a couple of minutes, the loop is through. So let's take a look at what we are getting by just doing a DataFrame conversion of the list we created, screener data. And let's call that screener DataFrame. So screener DataFrame is looking like this. Pretty nice DataFrame containing the ticker, company name, the market cap, price earnings ratio, dividend yield, the sector, the industry, and the currency. So a lot of valuable and nicely structured data here, which we can work with. Before moving on, we have to do a quick check of the data types. So just pulling the info here on that data frame, and you see we're getting object data types for the market cap, price earnings ratio, and dividend yield, which is bad because these are numeric values. So we have to do a data transformation here. And how I'm doing it is I'm just going over those columns and transform them. So let's call that numeric columns, then just pass market cap, price earnings ratio, and dividend yields. And now I'm just going to loop over those columns. So for call in numeric columns, then access that column and just do a Pandas to numeric typecast here. Again on that column. And for every error which is potentially occurring, I'm just filling an NaN value here. So that is what Coerce is doing. So executed. Let's check again. Now perfect. We have market cap, price earnings ratio, and dividend yield as floating values, and everything else as object values. So all good. Everything is fine. Now next, we have mixed market caps, meaning we have a market cap which is in yen, and we also have market caps which is in rupee. We also have market caps in US dollar and so on. But in order to make them comparable, we have to bring them in one currency, and I'm just picking the US dollar here, the world currency. Yeah, even oil is only traded in US dollar. So we are going to convert that all in US dollar. How? You just pull the most recent FX rate for those currencies and then transform those market caps to market cap in US dollar. So let's pull all currencies. So we can just use YFinance for that. So let's take currency tickers. Now we need the ticker symbol for the rates. That's straightforward. You just take JPY equals X, AKD equals X, and rupiah equals X. These are the tickers. And then you just pull exchange rate data. Just create a ticker object, YF tickers on the currency tickers. And then I'm just quickly show you how this is looking like. Then you just get an object here. And in order to get something out of that, you would access, for instance, JPY, JPYX. And then you can pull the info on that. And you see here, I can just pull the previous close to get the last available exchange rate. So get previous close. So with that, I have my exchange rate. And with that logic, I just create a dictionary out of exchange rates. So let's call that exchange rates. And just for purpose, why I'm doing that is simply I want to map this dictionary with the exchange rates to this column and then just transform the market cap values with the given currency exchange rate. We'll do that in some seconds, but that's a rationale why I'm creating a exchange rates dictionary here. So first of all, JPY, and then just the story I just told you. So just pull the exchange rate for that one. Same story for all other currencies. So HKD is HKD in relation to US dollar. And last but not least, our dear Indian friends, INR. So we are good with that. So let's just double check just to be sure. So it looks very good, right? Yen 157 US dollar, HKD 7.77, rupiah 85.78. So we can use those exchange rates now. And as I just said, we are just applying those exchange rates based on this currency values on the market cap. So I'm going to create a custom function and apply that function on every single row and do that check. So take the currency and then apply the exchange rate on that market cap. And out of that, I'm going to create a new column. So we need a function which is doing that conversion. So convert to US dollar on a given row. And every row you just check if that row currency is in the exchange rates and the market cap is not an NAN value. Market cap is not an NAN value. Then you want to do the calculation. The calculation is simply the market cap divided by the exchange rate. So market cap divided by exchange rates, row currency. So this is super straightforward. It's just going into that dictionary, then screens for, let's take the first row here, JPY, and then is applying this value and takes the market cap and divides it by the JPY exchange rate. Pretty cool, right? So we also need a case for the US dollar values. So in case this is a US dollar value, you just return the row market cap because it's already in US dollar. So this will capture the US dollar market caps here. And then you just take the screener data frame, create a new column, so market cap in US dollar. And then you take screener data frame and apply this function on axis 1. So this is super convenient and you should be able to use that for Pandas because it's super powerful, it's super nice. So you can just create a custom function and use the apply function from Pandas and apply a custom function on every single row and also on every single column of the data frame. So in this case, on every single row, I'm applying that. So it is doing exactly what I just explained to you, how this function is doing row-wise. So at some point I messed up, but we will figure out. Name exchange rates is not defined. Exchange rates. Yeah, exchange rates. Just a typo here, so nothing to be concerned here. Just execute it again with the right syntax here, and then you see that we have a new column, market cap in US dollar. Pretty nice, right? Now, just to be sure, let's pull the data types again, but also the market cap in US dollar is a floating value, so all good. Next step. Now, in the current screener data frame, we don't have any indication to what index this is belonging to. So meaning, for instance, this ticker or this Nisui corporation, in what index is that? So we need to pull that information somewhere. There are millions of ways to do that. So you can again work with the dictionary and say if it's JPY, then take the Nikkei. If it's INR, then take the NIFTY and so on. But I'm showing you another approach just to keep it more entertaining or keep it more interesting. because we already have that information in the tickers data frame. And we have a communality between this data frame and this data frame, so we can just merge those data frames. I think that's a nice way to do it. So you see you have the index here as the market, and you have a ticker. So you can just merge on the ticker column and take this index column and append it to the screener data frame. So let's do that. That's also pretty nicely to do in Pandas. So screener data frame merge with the ticker data frame, and we only need the ticker and the index, because the ticker we merge on and the index we want to have. And then you just define on what you want to merge, and as I said, it's on ticker, and by default this is a left join. So if you execute that, you will see that you nicely get the Nikkei for the Japanese stocks, the NIFTY for the Indian stocks, and so on. So let's just reassign that to get this into the screener data frame, and then we are good. Then I'm going to rename that. Index is a bit misleading in data terms, so you can just rename that. Rename columns, then just pass the index and name that market. And we just in place, so we directly get the screener data frame with the proper column name. So screener data frame looks like this. We have a market, Nikkei, for the Japanese stocks, and so on and so forth. So just optionally, you can save that to a CSV file. So global stock screener CSV. So we have it somewhere. Set the index to false, so you don't write back the index here. And then you have it nicely stored somewhere. All right. Last but not least, some ranking or some analysis on those pulled data, or on this pulled data. So let's create a function to achieve that, just calling that rank stocks, and this is just ranking stocks depending on whatever you want to rank. So this is taking a data frame or a screener data frame, a column you pass, then it's setting the ascending way to sort to false, but you can change that by providing this argument and set it to true. And then you need the top n, so just the top stocks you want to have. So top n is 20 by default. If you want to have the top 5, you just pass the top n argument when calling this function. And now it's just creating a rank. So you don't necessarily need to do that, but I think it's a nice thing to have. So this is creating a rank for a given column. So the column you pass to this function, and then it's ranking, ascending depending on whatever you pass to this function. Taking the min method here, and then you create a rank data frame by just sorting by this rank. And then you only take the top n values. And finally, you just return the rank data frame, and then only want to have the rank, the ticker, and the company name, so you don't have to read through this cryptic ticker. And you also want to have the column you pass to this. So this is super nice. You just can use that to rank on whatever column you are passing. Let me show you how this is working. So if you call this function, pass our screener data frame, and then, for instance, as a column, the market cap in US dollar, and then take let's take the top 10. Then you will get your company sorted by the market cap, pretty similar to what I showed you in the beginning. So top 20, we have Tencent here in as well, and then you can play around with that for yourself. So let's also take a look at the price earnings here, PE ratio. Then in this case, you set ascending to true as the price earnings ratio. You want to sort ascending. You want to have the lowest values first. Then you have the price earnings ratio sorted here. So yeah, play a bit around with that in the next video. So I mean, the video here needs a bit of traction in order to do the next video. So just like the video, obviously let me know your thoughts below. If this is getting like, I think 10k views or so, I'm doing the Streamlit conversion. So you just have to do a couple of amendments and then put that together in a dashboard. But I'm happy to do it. Just give the video some love, or just sign up as a channel member. I will keep track of if you follow my lead there. And yeah, I'm happy to do the next part. So thanks a lot for watching and looking forward to seeing the upcoming videos. Cheers, bye bye.